Hi guys, today we're going to talk about the distributive property in a little more detail. And the I can statement we're actually working on for this unit is I can use the properties of numbers when multiplying integers. But two other I can statements that we're going to touch upon are I can use the distributive property to show the sum of two numbers, 1 to 100, in different ways. And I can understand the problem in the parentheses can be thought of as one number or the sum of two numbers. Now, those are the two areas we're going to be touching on in our lesson tomorrow. So, it's very important that you understand how to use the distributive property because this is where we're headed with it. So, using some tiles, let's build two different rectangles. We're going to make one rectangle that is a 3 by 2 and the other is going to be a 3 by 4. So there's our 3 by 2, and there's our 3 by 4. And the question is, what is the total area of the two rectangles? Well, that's pretty simple. I would find the area of the first rectangle by multiplying. 3 times 2, I get 6. I can also count 1, 2, 3, 4, 5, 6 tiles. That's the area. And find the area of the second rectangle. 3 times 4, that's 12. And then to find the total area of both of them, I just take the sum of those two products, or those two areas. Okay, and I get 18. But here's another way to get the total area. If I were to push these two together, now look what happens to the length of my rectangle. My original rectangle, right here, was a 2 by 3, and my second original rectangle was a 4 by 3. But when I put them together, I now have 1, 2, 3, 4, 5, 6 is my length. So 2 plus 4, 6. Okay? Keep that in mind. So another way to find the total area is 3 times the quantity of 2 plus 4, or what I got when I put them together. And if I work that out, 2 plus 4 gives me 6, using the order of operations, and 3 times 6 gives me 18. So my area doesn't change just because I push the two rectangles together. So from this activity, we can conclude that 3 times the quantity, 2 plus 4, is the same as 3 times 2 plus 3 times 4, or 3 times the quantity 2 plus 4 equals 3 times 2 plus 3 times 4. Let's try another example. Let's build a 4 by 2 and a 4 by 4 rectangle. And then write an expression for the total area of these two rectangles. Well, I'm going to look at my first rectangle. And notice to get the area, I get 4 times 2. And to find the area of my second rectangle, I get 4 times 4. Now let's look at those two little mini expressions that give me the area for each of these individually. What do they have in common? Both of them have a 4. Both of them are multiplying. Let's take a look at what happens to that 4 and that fact that we're multiplying, that operation, and see what happens using the distributive property. Note also what's left, 2 plus 4. So if I want to write this a different way and push them together, I would get 4 times the quantity 2 plus 4. Notice what happened. I started off with 4 times 2 plus 4 times 4. I noticed that both of those little expressions have a 4 being multiplied by something. So I removed that from both expressions and put it by itself outside. And then multiplied that by the quantity 2 plus 4, or my two original lengths of my rectangle. So if I look at my two possible solutions, 4 times the quantity 2 plus 4, which really, when I work it out, I get 4 times 6 using the order of operations, which is 24, or 4 times 2, which is 8, plus 4 times 4, which is 16, which gives me 24. So they're the same. So I can say 4 times the quantity 2 plus 4 equals 4 times 2 plus 4 times 4. And when we're using the properties, we're just rewriting expressions in different ways, but they're still going to be equivalent. So let's put the tiles away. On your own, I want you, in the work section of your notes, to write 2 expressions for the total area of these triangles. You can go back and watch any portion you need to, but when you're done with 1 and 2, hit play again, because we're still going to talk a little bit more about the distributive property. So pause your video now, do numbers 1 and 2 in your work section, and then hit play. So what does it mean to distribute? Well, if we look at the distributive property, we can think of a teacher. And the teacher distributed papers to the class. And when she's done, every student has a paper. It's been distributed. Distribute the number, when we use the distributive property, we distribute the number outside the parentheses to each number inside the parentheses by multiplication. So if I want to look at a few of these problems, 5 times the quantity 3 plus 4, I would do 5 times 3 plus 5 times 4. If I want to extend that even further and write a third expression, I could say 5 times 3 is 15 plus 5 times 4 is 20. So now I'm showing this multiplication problem as the sum of 2 numbers. Now the distributive property also works for subtraction in the same exact way. I still need to distribute this 5. So 5 times 4 minus 5 times 3, because there's a minus sign in my original problem. To take it a step further to show it as the sum of 2 numbers between 1 and 100, I would simply multiply 5 times 4 to get 20 minus 5 times 3 to get 15. So when I'm using the distributive property, I can really write 3 expressions. And we're going to talk a lot more about this in class, but you're going to be expected to write 3 expressions using the distributive property. So, according to the order of operations, you must do what's inside the parentheses first. That's what we've been talking about in class. So, 5 plus 6 is 11, and then 4 times 11 is 44. However, just as we had mentioned in the previous slide, you can also use the distributive property to solve this. You can do it by distributing the 4 to everything inside the parentheses. So, you would do 4 times 5 plus 4 times 6, and voila! You have rewritten the first expression using the distributive property. If you wanted to go a step further, you would simply multiply 4 times 5 to get 20, plus 4 times 6 is 24. So now you have 3 expressions using the distributive property that are all equivalent. Look, 3 times 5 is 20, 4 times 6 is 24, and that also gives you 44, just like 4 times the quantity 5 plus 6. Now it's your turn. In the work section of your notes, rewrite each of these following expressions 2 different ways using the distributive property. So for example, in the first one, I would do 6 times 4 plus 6 times 3. That would be one expression. And my second expression would be 6 times 4 is 24 plus 6 times 3 is 18. So there are my two different expressions using the distributive property to represent that first one. Now, in the work section of your notes, go ahead and complete these next 7 problems. But we're not done. So when you finish these 7 problems, hit play. We've got a little bit more to talk about. Again, you can go back and watch any portion of this video as many times as you need to, just to make sure you've got this down pat. Okay, so what's the point of using the distributive property? Well, it helps us to do mental math. Let's look at this problem. 5 times 32 might be a problem that's difficult to do in my head. But if I think of 32 as a sum, I can rewrite it as the sum of two numbers that I can do in my head. So in my head, I'm thinking 5 times 30 is 150, and 5 times 2 is 10. In my head, I can do 150 plus 10 to get 160 much quicker than if I tried to think 5 times 2 is 0, carry the 1, 5 times 3 in my head, and tried to multiply it. That would be more difficult. But using the distributive property and turning this problem into a product of a number and the sum of two numbers, 30 plus 2, that are easy to do in my head, I was able to solve this problem mentally. So now it's your turn. Look at the following, the 3 problems that I have on the screen. Rewrite each of the following problems using the distributive property. Rewrite it 3 ways using the distributive property. So, if I look back at the problem before, here's the first way I use the distributive property. The second way I would write it would be 5 times 30 plus 5 times 2. And the final way would be 5 times 30 is 150 plus 5 times 2 is 10. So that is 1, 2, 3 ways to rewrite this problem using the distributive property. Now you use the distributive property to rewrite these 3 problems, each 3 different ways. You can pause the video to answer these 3 questions. You can go back and rewatch any portion or all of the video as many times as you need to, and then WSQ in your notes. We are done with the video, so pause it and complete number 4.